Hello everyone, in this video we are going to learn the 8th lab assignment of the subject DDCO, that is to design a VERILOG program for implementing various types of flip-flops such as SR, JK and D flip-flops. First we will discuss about SR flip-flop. Here is the circuit diagram for SR flip-flop. Here S and R are the inputs and CLK is the clock and outputs are Qn and Qn bar. Here this is the truth table for SR flip-flop. Here if the clock value is 0, then the S and R value will be don't care and Q of n plus 1 is Qn. And if the clock value is 1, then S and R value are 0 0, then the Qn plus 1 value is Qn. Here clock value is 1, therefore clock value is 1 and 1 here, and S and R value are 0 0. S value is 0 and R value is 0. Then 0 NAND gate 1, that will give 1, and this also give 1. Then the Qn plus 1 value will be Qn. Okay. Then in the second condition, S and R value will be 0 and 1 respectively. Here S is 0 and R is 1. 1 1 NAND will become 0 and here it remains as 1. Then if a single 0 comes in the NAND gate as input, then the output will be 1 itself. Okay. If Qn bar is 1, then it will go here. 1 1 NAND gate will give 0. That is Qn is 0 for S value 0 and R value 1. Like this, these two cases also same. Here this is 1 and 1, this key is invalid case, because if here S is 1 and R is 1, then it will give 0 0. Then it will obviously NAND gate will give 1 and 1. So these two cannot be equal because Qn is there and Qn bar is there. If it is 0, then it will be 1. If it is 1, then it will be 0. Like that it will be written. But in this case it cannot be happen, so it is invalid. Okay. Here is the HDL program for SR flip-flop. Here we are taken module name is SR flip-flop, and S and R are inputs, Q and QB are outputs, clock and reset are also inputs. Okay. Here we are declaring the inputs as S, R, clock and reset, and outputs are Q and QB. And register Q, QB always at post edge clock begin if reset of Q less than or equal to 0, else begin case of SR. Here it will look about the cases of SR, that is inputs of SR. Here S is this and R is this. If S and R value are 0 0, then Q value will be Q. Okay. If S and R value are 0 and 1 respectively, then Q value will be 0. That is, we have studied in this. Okay. 0 0, then Qn plus 1 value will be Qn, and 0 1, then it will give 0. 1 0 1 and 1 1 is invalid. Like that we are writing 0 1 is 0, 1 0 is 1 and 1 1 is, this refers to invalid. Okay. Then end case and the this begin will be ended here and assigning Q be not of Q. Okay. Then end module. Now we will discuss about JK flip-flop. Here we are taking the inputs J, K and 1 clock, and here also taking the inputs of previous inputs as input for the next JK. Okay. Here we are using this because in SR flip-flop we have one problem here, that is invalid problem. To solve this we are using that circuit. Okay. here we will see, okay, if j and k are 0 0, that is j and k are 0 0, then the NAND gate, if one single input is 0, then NAND gate will give 1. Here also same 1, and like in SR flip flop it will give Q, okay. And the next is 0 1. If the j is 0 and k is 1, then this will give 1, and for this it is not 1, okay. Here it will take the inputs, that is Qn. If Qn is 0, then it will give 1, and then SR latch will happen, then it will give 1, okay. Qn is given. If Qn is 1 here, then it will give 0. Then the next NAND gate, if single 0 is present, then it will give 1, okay. And here Qn is taken as input, and in 1 1 the NAND gate input is 0, then the Qn is 0 here, and the Qn bar is 1, okay. And in the third case 1 0, j is 1 and k is 0, then it will give 1 here, and here it will take the input from this, that is Qn bar. In the previous case we have given that there is 1, then it will give 1 here, so this will give 0, NAND gate 1 1 1, and the NAND gate of 1 it will give 0, okay. And here it will become 1, and here it will become 0. Then if a single 0 is present in the NAND gate input, then it will give 1, and this 1 comes here 1 1, then the Qn bar will become 0. So for 1 and 0 the Qn value become 1, that is 1, and here 1 1 is the input. If j and k are 1 1, okay, j and k are 1 1, then it takes from here, okay. Here it is 0, Qn is 1 here. In the previous case Qn is 1 and Qn bar is 0, that is Qn bar is 0. Qn bar 0 is taken here, okay. Here 0 1 1. If single 0 is present in the NAND gate, then it will give 1, and here all are 1, okay, because from this Qn is 1 here, and this Qn is taken here and it will give 0, okay, because NAND gate of 1 will become 0. Here is 1 and here is 0. If a single 0 is present here, then it will give 1 here, Qn bar is 1, and the Qn is taken 1 from this, and 1 1 will be taken as input for this NAND gate, and this will give 0. So Qn is 0. That is, if here Qn is 0, then it will give Qn as 1 as input, that is Q bar. If Q is 0 as the input here, third input, then it will give Q bar, that is 1 will give 0 and 0 will give 1. So we have written Q bar, okay. Here is the Verilog code for JK flip flop. Here the module name is JK flip flop, and the inputs are JK, CLK, that is clock and reset. Output is Q and QB. Here register Q and QB. Always at POSET CLK begin if reset of Q is less than or equal to 0, else begin case of JK. Here if 0 0 comes in the inputs, that is JK, J value is 0, then K value is 0, then the Q value will be Q. That is we have seen in this truth table, okay. If J value is 0, K value is 1, J value is 0 and K value is 1, then the Q value will be 0, that is here. And if the J value is 1 and K value will be 0, then Qn plus 1 is 1. For J and K, 1 and 1 each value, then the Q value will be not of Q, that is Q bar, okay. Now we will discuss about the D flip flop. here is the circuit diagram for D flip-flop, and here is the truth table. Assume that we are having the clock 1 1, and here if the D value is 0, then the Q1 plus value is 0, that is Q1 value will be 0. If the D value is 1, then the Q1 plus value will be 1. If the D value is 1, then the Q1 plus value will be 1. Therefore, we can write this equation for this D flip-flop as Qn plus 1 is equal to D. What is the input D value? Then that will be the output for this. Okay, like this D flip-flop works. Now we will see the VERILOG program for D flip-flop. Here the input is D, clock and reset. The outputs are Q and Q bar, register Q and Q bar, always set, poset, clock. If here case D, it is D, okay, case D, if D is 0, then the output is 0. If D is 1, then the output is 1. Then Q bar will be not of Q. Okay, that's it. For JK flip-flop, they are given that the input as 0 and 0, J and K value are 0 and 0, and the clock value is 0. Then the output we had seen that Q value will be X and Q bar value will be X, that is don't care. Okay. In the SR flip-flop also, if clock value is 0, then Q and Q bar value will be X, that is don't care. Here D flip-flop also same. If the clock value is 0, then the Q and Q bar value will be XX, that is don't care.